Hello students, in this video you are going to study about the electrolysis of fused or molten lead bromide. First point, electrolytic cell. A vessel or a container or a setup in which electrolysis is carried out is called electrolytic cell. In this process of electrolysis of molten lead bromide, a silica crucible is used as electrolytic cell. Reason: because silica is non-conductor of electricity but good conductor of heat. And second point, non-reactive, does not react. And third reason is it can withstand high temperature because of its high melting point. Now, second point is there, electrolyte. Molten or fused lead bromide is taken in silica crucible, which is electrolyte. Reason: solid lead bromide contains lead ion Pb2 plus and bromide ion Br minus. These ions are held together due to a strong electrostatic force of attraction, and these ions are not free to move. Therefore, solid lead bromide is non-conductor of electricity. But in molten or fused state, these lead ions and bromide ions become free to move. This is why molten lead bromide or fused lead bromide is used as electrolyte and is taken in silica crucible. To keep it in molten state, silica crucible in which it is kept is heated continuously from outside. It is heated continuously from outside. Why is it heated externally continuously? To keep this lead bromide in molten state, because this molten lead bromide has tendency to solidify. This is why it is constantly heated from outside. Now, third point is their electrode, a metal wire or plate or graphite rod or gas carbon rod through which current enters and comes out, leave the electrolytic cell, are called electrodes. Here, number A, anode. An inert electrode, graphite is used as anode. Graphite is immersed in the molten lead bromide and it is connected to the positive terminal of the DC power source, direct current source, or positive terminal of the battery, 12-volt battery. This graphite electrode, which is connected to positive terminal of the battery or direct current source, is called anode. Here, anode is, graphite is preferred to other inert electrode like platinum because the product bromine vapor formed at anode does not react with graphite. Number B, that is cathode. An inert cathode, graphite or platinum, is immersed in the molten lead bromide and is connected to the negative terminal of the battery, which is cathode. Next point, region in electrodes region, I told you graphite anode is preferred because it does not react with bromine, but if platinum anode is used, then platinum react with bromine. Now, next point is there, fourth point. First I told you electrolytic cell, second I told you electrolyte, third electrode, fourth dissociation. Lead bromide undergoes dissociation in fused or molten state to produce lead ion Pb2 plus ion and bromide ion Br minus ions. Next, ions present in the electrolyte. These ions in molten lead bromide, Pb2 plus and Br minus ions are present. Next point, temperature. The temperature of electrolyte is 380 degree, 381 degree because melting point of lead bromide is 373 degrees centigrade. Then this is why melting point of electrolyte is maintained around 380, 382 degree like that. And next point, after that, migration of ion. When key is pressed, switch is on, direct electric current passes through molten lead bromide. Lead ions Pb2 plus ion migrate towards cathode, that is cathode attract Pb2 plus ion, and bromide ion Br minus ions are attracted towards anode. Bromide ion migrate towards anode. Reason: cathode is connected to negative terminal of the battery. This is a negative electrode. It attracts the cation like lead ion. And anode, graphite anode is connected to positive terminal of the battery, that is positive electrode. Therefore, it attracts the anion, that is bromide ion, and bromide ion migrate at or towards anode. Now, next point, their reaction at anode. Lead ion, bromide ion Br minus means that is anion migrated at anode, give electron to anode and changes from bromide ion to bromine atoms. Two of these bromine atoms combine to form bromine molecule, and these bromine molecules produced at anode are observed as reddish brown bromine vapor. Then reaction as given there, Br minus loses electron to form bromine atom and bromine atom combine to form bromine molecule at anode. Next, cathode reaction. Lead ion Pb2 plus ions migrated at cathode, gain electron, take electron from cathode and change to lead atom and are deposited around the cathode near the bottom. Now, next point, observation. Reddish brown vapor of bromine is observed at anode and silvery gray or grayish white lead metal in liquid state is observed at around the cathode near the bottom. Melting point of lead, reason, melting point of lead is 327 degrees centigrade. Therefore, lead produced over there at cathode changes into or remains in liquid state because the temperature of electrolyte is more than the melting point of lead. Temperature of electrolyte is about 381-382 degree, but melting point of lead is 327 degree. This is why lead produced near the cathode or at the cathode is in liquid state. Next is, lead is denser than lead bromide. Therefore, it does not float on the top. It goes down, settles down, sink there and remains near the bottom around the cathode. This is about observation at anode and at cathode. Next, some reason once again. First is, silica crucible is used because silica is non-conductor of electricity but conductor of heat. Second point, it is non-reactive, means does not react. And third point, it can withstand high temperature. Second question, lead bromide is taken in molten state because solid lead bromide contain lead ion and bromide ion, but it does not conduct electricity because these ions are held together by a strong electrostatic force of attraction, that is ionic bond. This is why they are not free to, ions are not free to move. But in molten or fused state, these lead ions and bromide ions are free to move. This is why lead bromide is taken in molten or fused state, and crucible containing lead bromide is continuously heated from outside to keep lead bromide in molten state. Next point, for question I am telling you, third, why is graphite anode preferred to other platinum electrode? Because to other electrode like platinum, because at anode bromine vapor, bromine is produced, and temperature is also there in the electrolyte 381, 380 or 382 degree, like that. At that high temperature, bromine is highly corrosive, bromine is reactive, it will react with platinum electrode. This is why graphite anode is preferred to platinum or other electrode. Next point, in the electrolysis of lead bromide, what is observed at anode? Reddish brown bromine vapor is observed at anode, and silvery gray liquid lead metal is observed around the cathode near the bottom in the electrolytic cell. Their diagram is also given. Everything I have explained. This is about the electrolysis of molten lead bromide. Thank you.